Welcome to the third and final video on testing the Fourier Sound Lab. In this video, I'll be focusing on Objective 5, showing the functionality of the Fourier menu. In the previous videos, we have proved the functionality of the sine wave addition, so I'll quickly create some sine waves to work with. Pressing Fourier menu, we now have a bunch of new additions. Attempting to compute a Fourier transform, we can see we agree to the graph, which, when zoomed in to the right place, we can see a Fourier transformation magnitude spectrum of 40 Hz, 50 Hz, and 60 Hz. This matches our input and so is correct. Adding another one would result in the same thing. This time on the same graph, we plotted our new 4 frequencies. Doing it again, the same thing will happen. Each of the colors represents our previous plots. Closing this, doing a manual Fourier transform, we can observe our now 5 frequencies on a manually integrated Fourier graph. This time, the peaks are more accurate, exactly at the frequencies at which we set them, whereas before, the FFT module was less accurate and did not give us much information about what happens in between. Closing this, we can open the polar winding plot now. Here, we can interact with the slider. Sliding around the winding frequency results in the waves being twisted around the axis more and more. The maximum value is the biggest frequency, and the smallest value is 0.1. As we can see, the graph seems to line up at the frequencies we have used. Adding a new sine wave, giving it a frequency, and plotting a polar winding plot, we now have a different plot, now more complicated. You can also set a frequency, for example, 65 Hz. The set frequency field is synced with the slider and sets the graph to whatever you put in there. Going back, pressing the compare FFT and manual transform, this plots the original FFT graph and the manual graph all on the same axis, showing you the difference in accuracy. For instance, zooming in to this place, we can see the blue lines, which represent the FFT spectrum, have a wide range of values. Meanwhile, my manual lines are accurate and show you the exact frequency that was found. Closing this, we can generate a spectrogram. Now we can visualize how each of the frequencies, represented by colors, take part in our superposed wave, which we have here. Closing this, we can also open a phase spectrum, seeing how the phase of our superposed wave is shifted by each individual frequency we have chosen to input. We can choose to plot these all at once, and the program will continue working. Closing all these, and closing the menu, we can reopen the menu anytime we like. Adding sine waves, putting in values, this will still work. However, putting in wrong values will trigger the error codes we have seen previously. Putting in values which are valid will trigger a correct graph. As we can see, the colors have shifted when I added a larger frequency. Also, removing values has the same effect. This is the end of the third and final video proving the functionality of the Fourier menu and the Fourier transform lab.